Okay, so this video covers the last two problems from the Unit 8H handout, um, which was the intro to trig stuff. In number 11, we've got triangle CMO, and it's got these three vertices, and the goal is to find the angle right here. Find the angle M. Now, the problem is I can't use trig on this triangle because I don't know if it's a right triangle, and it doesn't look like one, so you can't use trig on non-right triangles. But we create right triangles all the time on graphs by making some slope triangles. So if I build a slope triangles around M, I've got this one right here, and I've got this one right here. And if you figured out what these lengths are, let's see, when I go up, it goes from 2 to 7, so that's 5 up, and across it goes from -6 to +5, so that's 11 across. And then the vertical part of this long, thin triangle on the right, it goes from 7 to -5, so those are 12 apart. And from 5 to 3, that's 2 apart horizontally. So what I can do is solve for angles in the red triangles here and here, right? So what I'll do is, since I like to use Greek letters for angles, I'll call the main one theta, that's M, that's what we're solving for. And then the first two Greek letters, instead of A and B, it's alpha and beta. Alpha looks like kind of like a fish, and beta looks a lot like a B. Now you can use other letters if you prefer. You can use A and B if you want. It doesn't really matter to me. But I'm just going to kind of stick with what's pretty common for math textbooks. So if I look at those three angles put together, they form this big right angle there. So I know alpha plus theta plus beta equals 90. The one that I'm ultimately hoping to find is theta, because that's angle M. That's the original angle M. So let me draw the one slope triangle that's got the side of 5, 11, the sides of 5 and 11, and this one's alpha. So the 5 is the opposite side, and the 11 is the adjacent side. So what I'm going to do is the trig function that uses opposite and adjacent is tangent. So I've got tan of alpha equals 5 over 11. And in order to get rid of the alpha, I'm going to have to do tan inverse. So remember, you can, in this class, you can write tan inverse of this side equals tan inverse of the other side. So 5 over 11 goes here, tan alpha goes there. But really, what you should get in the habit of doing is just skipping this part here and just going straight to alpha equals tan inverse of 5 over 11. Because technically, even though this step is always right for our class, it doesn't work with certain other advanced math stuff where you can just cancel the tan and tan inverse. It only works really with acute angles where you're guaranteed that it works every time. So anyway, tan inverse of 5 over 11, let me call up the calculator here, turn it on. So tan inverse is second tan, and then we got 5 divided by 11, and that is 24.444 degrees roughly. Okay, and so then I need to solve for beta. So let me redraw that triangle. Let me shrink this down here. Oop. So we'll make that a little bit smaller. And then if I draw that long, thin triangle, 2 here, 12 here, and beta was the angle up there. So 2 is the opposite side, 12 is the adjacent side. So again, this is going to use tan. So tangent of beta is going to be 2 over 12. And so then if I want to isolate the beta, I do tan inverse. So beta is going to be tan inverse of 2 over 12. And then if I type that in, I've got second tan. So for tan inverse, 2 divided by 12, hit enter, 9.462 roughly. So beta is about 9.462. Well, theta is the one that I want, angle M. Measurement of angle M equals theta, which would be 90 minus alpha and beta put together. So that's 90 minus 24.4 oops, 24.444 repeating, or not repeating, just 444, plus 9.462. And so if you work that out, we've got 90 minus, and then since I have the decimals stored all the way out here, I'm just going to enter there and cut and paste, add to it this other one, cut and paste. And we got 56.094 degrees. So that's how big angle M is. So really what trig allows you to do is now you can solve for any angle on a graph as long as you have some endpoints there. Okay, so 12. 12, we've got this triangle floating around down here. And the goal is to figure out what angle C is and what AC is. And you can't use PyVag because it's not a right triangle. And I can't use trig on this triangle because it's not a right triangle. But I can create right triangles by dropping a line right here. One that's right angled, that forms right angles. So it's an altitude from A. So if I call the height, I don't know, let's call this Y, and the base of this part here X, then this part over here, if the right side is X, then the left side would be 14 minus X. Since the whole thing was 14, I'll put the X up here. And I can't work on the on this triangle over here yet because I don't know anything about it. But I do know the 9 and the 63 in this triangle over here. So let me draw that triangle by itself. And I've got 63 degrees, 9, X, and Y. So in this problem, if I use the 63 as my reference, the X is going to be the adjacent side, the Y is the opposite side, and the 9 is the hypotenuse. So, I don't know, let's solve for X. So adjacent and hypotenuse are what I'm going to use here. So that's going to be a cosine rule. So cos 63, cos of the angle, equals the adjacent side over the hypotenuse. And then to get rid of that 9 on the bottom and isolate X, I'm just going to multiply both sides by 9. So you get 9 cos 63 equals X. And so if we plug that in, we'll get that X is 9 times cosine of 63, 4.0859. We'll just round it to 6. And then, so here, that's this part. That part is 4.086, which means we can get this part because it's just 14 minus that other part. So let me call this back up. 14 minus the previous answer. So this part is 9.914 roughly. Okay, so then we also need Y. So let me get that. So in that one, we're going to use the opposite side and the 9, which is the hypotenuse. So the one that uses opposite and hypotenuse is sine. So sine of 63 is going to be Y over 9. And then when I multiply the 9 over, I get 9 sine 63 equals Y. And Y ends up being, I don't know, let's see, 9 times sine of 63 degrees. By the way, my calculator is already in degree mode. If you're getting answers different from this, make sure you switch that radian to degree. Okay, 9 sine 63 will be 8.019 roughly, about. So this guy right here is 8.019. Okay, so one of the things I need is AC. Well, in order to get AC, we don't have any angles, so I can't use trig, but I can use PyVag here on this right triangle. So AC squared is going to be 9.914 squared plus 8.019 squared. Well, I actually have the full decimals still in the calculator, so instead of just rounding, I'm just going to come up here and cut and paste that and square it, and then add the other answer that I have and square that, and then I don't have to worry about the rounding. So AC squared is going to be 162.594. So AC is the square root of that, so I'm going to do square root, And then instead of rounding again, I'm just going to cut and paste the previous answer. And I get 12.751. And this is the final answer is what you want to round to 3 places here. To get angle C, well, I've got that right triangle there where this is 8.019 and this is 9.914. And here's angle C. This is the opposite side. This is the adjacent side. So if I wanted to use trig to solve for C, I'd have to use the tangent because tan of my angle is the opposite side over the adjacent side. And since I want to get the angle now, I'm going to have to use inverse trig. So if I did tan inverse on both sides, I'd get C equals tan inverse of 8.019 divided by 9.914. And then these are still stored in the calculator, so I can cut and paste to save myself from a little bit of rounding issues. So tan inverse of the 8.019 divided by the 9.914. Where's that guy? There it is. And we get 38.968 degrees. Okay, I hope that helps some, and I'll see you guys soon.